kia ora koutou katoa. Thank you so much for joining us today in the first of the Passivhaus season, and this webinar is entitled Passivhaus, Our Common Future. We had planned for today to be the opening day of our Passivhaus conference, but we're absolutely thrilled that the original speakers, from some of the original speakers from that conference were able to join us today. So we have a fantastic lineup. We have the Honourable Dr. Megan Woods will be opening the webinar today. We have Deanna Erdvorsatz from the Intergovernmental Panel on Climate Change dialing in later on. And we have Dr. Michael Jack from Otago University. We have a representative from Auckland University of Technology. And finally, we have Brian Berg from Kangaroa. So absolutely delighted. I'm going to kick off to pass over to our main sponsor for this webinar, Alex Holly from Amiga Windows. Thanks so much.
Hi guys. Amiga Windows and Doors is really proud to support Passivhaus Institute of New Zealand. I've been a personal fan of Passivhaus since my time at university. I attended a course ran by Cara, who runs the Passivhaus Academy of New Zealand, and I since then have been hugely interested, and I think the future of New Zealand housing is passive, and one day I hope to build my own. A bit about us. Amiga is committed to providing products and services that improve the energy efficiency and livability of New Zealand's housing stock. We are also committed to the manufacture of aluminium components that have both a high recycled content of aluminium and a low embodied carbon. Our aluminium extrusions are 90% better when it comes to CO2 emission versus the global average. We've been producing thermally broken aluminium windows for a number of years now, and we see the benefits of firsthand of higher performance building components. Thank you for your time, and once again, we are very, very proud to support Passivhaus New Zealand and this webinar.
Thank you so much, Alex and Amiga. So we're delighted to introduce the Honourable Dr. Megan Woods, whose portfolio is very aligned with Passivhaus. She's a Minister for Housing, Energy and Resources, and of course, Research, Science and Innovation. Thank you so much for speaking with us today, Dr. Woods. I'll hand over to you.
Well, thank you, Amy, and kia ora koutou, everybody. And I'm so pleased to be here today to help you officially open the South Pacific Passivhaus season. Over the next few months, the Passivhaus season will investigate the theme of Our Common Future over a series of 4 webinars. As the theme suggests, the very real implications of climate change and international commitments to mitigate its effects are shaping our collective future. In New Zealand, the built environment contributes around 20% of our country's overall carbon emissions, which means improving the energy and life cycle carbon efficiency of our homes, buildings and infrastructure has become both a shared and an urgent goal. Over the course of the Passivhaus season, you can expect to hear from a highly experienced lineup of local and international speakers who will discuss projects, challenges and lessons learned on this shared journey. Today we kick off the conversation by discussing passive housing developments in the context of social housing and multi-generational living. But before we begin, I'd like to acknowledge and thank our sponsors and today's presenters who are all experts in their fields. As the Minister for, as you said, as the Minister for not only housing but also energy and resources and research, science and innovation, discussions around these kinds of projects and what they mean for social housing and multi-generational living is an incredibly interesting topic. The government believes everybody has the right to a warm, secure, affordable home, whether they rent or own, and we are making positive steps to accelerate the supply of housing and help more people into homes. At the same time, we understand the need to ensure we protect our natural environment, mitigate climate change and transition to a more sustainable, low emissions economy. The government has made tackling climate change a priority. In 2019, we passed the Climate Change Response Amendment, or the Zero Carbon Act, which aims to reach net zero carbon emissions by 2050. And in 2020, we declared a climate emergency, committing to urgent action to reduce our emissions. In 2020, we also set up the Carbon Neutral Government Programme to accelerate the reduction of emissions within the public sector. As a government, we know that our responsibility is to lead by example, and we've set the ambitious goal of achieving a carbon neutral public sector by 2025. There are already many businesses and communities leading the way in this space, and together we are working to transition to a low emissions economy and future. With our country still in urgent need of more homes and infrastructure, the construction sector faces an inherent tension between the need to build more homes at pace and lowering emissions while it does that. As I mentioned earlier, the building and construction sector currently accounts for around 20% of our carbon emissions. These emissions are not only created when buildings are constructed, but through the energy and water they use over their lifetime and the deconstruction waste at the end of life. If New Zealand is to reach its climate goals, including net zero carbon by 2050, the building and construction sector must play its part. The country is in the middle of the biggest building and infrastructure boom ever seen, and the assets that we're building today will be around long after 2050. This means our opportunity to decarbonise, to make the transition easier and future-proof our built environment is right now. The Ministry of Business, Innovation and Employment has produced a roadmap for how the sector can do this in the Building for Climate Change program. This is a long-term work stream aimed at reducing emissions from constructing and operating buildings and making sure our buildings are prepared for the future effects of climate change. Kāinga Ora, the government's urban development agency and public housing landlord, is leading several low-carbon initiatives to support the Building for Climate Change program and help us lead by example. The organisation provides homes to around 200,000 of New Zealand's most vulnerable people, and due to the nature of its work, 99% of its carbon emissions come from the construction activity, maintenance of its assets, and energy used by its customers. To help meet both Embers targets and the government's carbon neutral public sector commitments, the organisation is currently investing in a life cycle carbon assessment software. This will enable all Kāinga Ora homes and infrastructure to calculate, report on and design carbon out of its projects, both at scale and at pace. Kāinga Ora is also working to make the tool, along with insights and learning, accessible across government agencies and the wider construction sector. This is what we are working towards in public housing, but what have we been doing to date? At Kāinga Ora, initiatives to lower emissions across its portfolio are already well underway. One major initiative is the Carbon Neutral Housing Program, which aims to decarbonise all public housing construction activity to low carbon by 2030. The program has a series of pilots underway that employ a range of approaches. Some of these include designing to meet Passivhaus standard, local renewable energy generation, off-site manufacturing, and using a range of low-carbon materials. Ultimately, the program aims to meet Embers 2030 to 35 climate change aspirations by 2024, demonstrating to the industry that it is in fact achievable today using today's technology. Later in this webinar, you'll hear about one of these projects known as Ngā Kāinga Anamata. But spoiler alert, this is a truly exciting public housing project with a firm commitment to sharing lessons and solutions with the industry. And the very special thing about Ngā Kāinga Anamata is that it will deliver exceptionally healthy and energy efficient homes for some of New Zealand's most vulnerable people. We know energy poverty is a very real issue for many living in public housing. Too often, families are left with the choice between heating their homes and putting food on the table. A warm, dry, healthy and comfortable home is a basic human need, and the public housing projects we're developing have this at their core. At the same time, through Kāinga Ora, we're working out how to affordably transition our existing public housing portfolio to be low energy and low carbon. We know the environmental benefits this will bring, but it's also how we reduce energy poverty and the likelihood of families having to face hard decisions around creating a healthy home. I'm truly excited for the future of public housing construction that our government is leading today in collaboration with the wider industry. We know that in some countries, Passive House is the benchmark for social housing. And I'm proud that New Zealand now has several Passive House projects underway for our public housing customers. Every step we take is moving us toward that shared future where we take responsibility for our impact on the planet and for the well-being of everybody on that planet. Thanks for having me here today. It's been an absolute pleasure, and I look forward to seeing what insights that the rest of the season brings. I'd now like to hand it over to Diana Erger-Volstats and the Intergovernmental Panel on Climate Change.
Thank you very much. Well, that's a real honor to be introduced by Your Honor. And I'm actually talking to you from our meeting on the synthesis report. So we are just writing the synthesis report of the Intergovernmental Panel on Climate Change. And I'm very, very delighted to share with you our very recent reports, the results of our very recent reports, and how hopefully they will inspire your work even more. I would like to talk to you about the latest report of the Intergovernmental Panel on Climate Change. We produce the so-called assessment reports every 7 years, and we produce 3 main volumes, one about physical science basis, one on impact, and one on mitigation. And our report in mitigation just was published just a few weeks ago. So all of this is very fresh. And you see this picture. And I will come back to this picture. This is not for this conference. You will be surprised. But actually, this is the cover page of our mitigation report. And this happens to be a passive house, a social housing passive house. So I think this is very good news for you, because that certainly symbolizes that, that passive houses are very much at the forefront of opportunities, which hopefully will help us keep climate at low levels. But let's first get to the climate science a little bit. So the first report of ours showed that, yes, recent changes in the climate system are already widespread, rapid, and intensifying, and unprecedented in thousands of years. In fact, that's a very conservative number, because if you look at actual numbers, global carbon dioxide concentrations and also ocean surface acidity has not been so high as today for 2 million years. Global average temperature has not been so high for at least 125,000 years. So already in less than a generation, we have turned back the geological clock of the planet by anywhere between 100,000 to even 2 million years. Concentrations of methane and nitrous oxide were higher than any time in at least 800,000 years. So in very short time, we have already changed our planet very significantly. Yeah, sorry. And what the reports also show that, unfortunately, there are some changes in the climate system from which there is no more going back. So which means they are irreversible. So for example, the ocean temperature will keep increasing even if we don't emit even a molecule more of carbon dioxide, will keep increasing for hundreds or even thousands of years. The same with many ice sheets, including the Greenland ice sheet, but also the ice sheet in Antarctica will keep melting and destabilizing for hundreds or even thousands of years. And along with these, the sea level will keep rising also for hundreds and thousands, or perhaps even on a 1,000-year timescale. But even worse, there are the so-called tipping points, many of which are actually, we might be very close to these tipping points. So there are these points in the climate system which are, and I don't know if you are very bored of my presentation, you maybe kind of swing on your chairs, and if you let go, you swing back. But if, when you were a child, perhaps you also tried it to swing back a little bit too much, and then the chair wouldn't return, but just fell back and there was nothing for you to do. Now, there are similar points in the climate system as well. For example, beyond a certain point, we are just not going to be able to stop the Greenland ice sheet, losing the Greenland ice sheet. And it's not very far, because it's anywhere between 2 and 3 degrees warming as compared to pre-industrial average. And we are already above 1 degree. and we may actually be reaching 2 degrees in the middle of the century, so probably well within lifetimes of many of you. Similarly, the collapse of the West Antarctic ice sheet, abrupt collapse of the Atlantic meridional overturning circulation, which is further for you, but for us, it's very crucial with regard to Europe's climate, the Gulf Stream. We already experience and see massive forest dieback all around the world. And this picture that you see, actually, I made this picture. This is very close to my home in the Tatra Mountains, where massive, virtually all forests have died, look like this. First as a result of big storms, then different pests, and also, I don't know if you experienced it in New Zealand, but definitely also around Hungary, many tree species which we are very used to just don't grow anymore. Anyway, so there are all these very difficult tipping points which once start, then they feed each other, and then there's no turning back from them. But before you get too desperate, the good news is that some changes can be slowed and others can still be stopped if we limit warming. And so really the point is that it's still, even if a lot of things are already very bad and many things will be even worse. So this is historic temperatures are fairly constant, basically in the ±1 range for 10,000 years. And we already just in a matter of 2 decades have shifted this by about 1 degree centigrade. It's almost certain that by end of this decade, actually, we are already going to reach the 1.5 degrees. Nevertheless, it's very different if you manage to keep it there and stabilize the temperature there on this blue line, or we keep going and going and going as the trends are going now, and then we may reach up to 5 degrees centigrade. And what these figures, the right side of the figure shows is the so-called burning embers diagram. It's one of the favorites of IPCC, which shows how severe the impacts are going to be as a function of temperature. So this is 1 degree, this is where we are now. And this is 1.5 degrees where we would like to be. And this is what we may experience at the end of the century. And the yellow impact is, which is already hard. The red is already very difficult. And the purple is something that you just cannot adapt to anymore. It's very severe. And you see that already now we are in the red in terms of some impacts. For example, and to you, they are much closer. For example, the Great Barrier Reef. We have already lost half of the coral ecosystems. For example, as I mentioned, we already have severe forest diebacks. We already are losing seaweed ice sheets and so on. But at 2 degrees, we are already entering in many systems, because you don't have to read the different bars, because we do these bars for all kinds of systems. But the point is that the purple, that the more reports we do, unfortunately, the red and the purple is going more down and down. In fact, in our previous report, we hardly had any purple. But now with more understanding, we understand that actually the impacts are going to be more severe with lower temperatures, the more and more we understand. Yes, so as I mentioned, it would be really important to try to keep the warming well under 2 degrees, or at best at 1.5 degrees. But unfortunately, what our report shows is that unless there are immediate, rapid, and large-scale reductions in greenhouse gas emissions across all sectors, limiting warming to 1.5 degrees will be beyond reach. What do we have to do to limit warming? This means that limiting human-induced global warming to any specific level, meaning 1.5, 2, 3, 5, 6, 10, any degree, does require reaching at least net zero carbon dioxide emissions, along with strong reductions also in other greenhouse gas emissions. So that basically implies that getting out of fossil fuels or leaving fossil fuels in the ground is non-negotiable. We just have to leave them there. So that means that if we have to do that anyway, the sooner we get there, the lower we will be able to stabilize temperatures. So the quality of life of not only one generation, but hundreds of generations to come really depends on how soon we can get this done. And that's a tremendous responsibility. Now, the good news is for you and for us that our report put a very big emphasis for the first time in the IPCC's history on demand and services. So not only asking always, okay, where can I get the next clean kilowatt hour of energy? But to first ask, do I really need that kilowatt hour of energy? Maybe first we should figure out how not to have to produce that next kilowatt hour of energy. And we have a whole dedicated chapter on that. And the chapter shows that actually we have a potential to bring down global emissions simply through influencing energy demand by up to 70% by 2050. Yes, buildings are among the biggest opportunities within that. However, it's important to point out that this can only happen if individuals are able to make the choices enabled by systemic changes, meaning that changes by housing, changes by cities, and so on. So we also concluded that buildings, it is possible to reach net zero emissions by the building sector by 2050. And the report really warns that action in this decade is critical to fully capture this potential because the long lifetime of buildings, and because every year we can only change only a certain number, a certain share of the building stock to net zero. So it does require ambitious policy packages, and its retrofitting is crucial, especially in developed countries. And what the chapter shows, which is also we showed already in our papers before, that by today, in every climate and virtually every building type, it is possible to convert every building to net zero energy levels, not net zero carbon, but net zero energy levels. And again, I want to come back to this photo, to the cover page of our report. And this is a nicer picture, but this is what our report will look like when published. And I'm really thrilled to show that, again, this is not only passive house, but this is a social housing. Actually, I think it's net zero building. It's social housing, and not only social housing, but it is made of of low carbon materials. In fact, probably mostly zero carbon materials because it's made of bio-based materials. In fact, it was also largely built by the community because it's for the poor. And so, and at the same time, you also see there are lots of greenery around it. So that means that also the carbon is building up in the soil around them. So I think it's a very nice example of a whole, and that also strengthened the community because of the common construction, and also with the small urban agriculture there. It's also building community and enhancing carbon capture. So altogether, I think it's a fantastic picture to symbolize that, yes, you can do mitigation in a way that's colorful and that's comfortable and that's better for the people. And that's exactly all what you're doing. And I think it's really encouraging that you should really go ahead and do more of this. And this is the paper in which was then cited by the IPCC report, in which we showed that net zero buildings are possible in virtually every building type, but in all climate zones, net zero energy buildings everywhere. And what we also showed that the costs are not prohibitive. In fact, for example, we have this cost figure in the paper which showed that on a per square meter level, passive houses cost actually less than average conventional buildings in a fairly large sample. And there are many such examples to show that this is not a cost question. For new buildings, it's definitely not a cost question. We also, yes, and but we have to go on, as we mentioned, when we build the buildings, it's really important to try to avoid as much as possible energy intensive and carbon intensive materials. So yes, maybe in New Zealand you have lots of timber, so that's very important. Not every country has a lot of timber. For example, in Europe we don't have that much timber. Nevertheless, this house is actually made of straw. So even straw is an excellent, and there are now multi-story buildings from straw, high industrial. I don't know if you have these such building materials available, but the point is that they capture carbon and they store carbon, and the longer the building stands and the longer a building is used, the longer it's storing the carbon. So it's a double win. So it is also very important. And sorry for the Hungarian text, but what we also showed that it's retrofit even for historic buildings is possible for net zero. This is actually going to be the new home of my university, and this is the biggest Art Nouveau building complex in the world. This is in Vienna. It's designed by Otto Wagner. It's a beautiful building ensemble. And what we showed in this research project, that even this beautiful old building district can be retrofitted to energy positive district. So turning this into power plant while, so the power plant of the 21st century, while observing the strictest national monument protection rules. So all of the characteristic and criteria for observing and respecting the work of Otto Wagner will be maximum preserved. And not only is this going to be an energy positive district, but what we are showing here, you don't need to look at the details. What we even showed in our research project, that actually even without switching a light bulb, even without turning the heater on, it's already cheaper. This retrofit, an energy positive level retrofit will be cheaper for my university to do than a regular retrofit. Why? Because of the district heating system would be very upgrading and maintaining a district heating system is simply more expensive than having very decentralized small heating systems. Now, this has changed, unfortunately, since then, because the supply chains have been, as you know, disrupted, and construction materials prices have skyrocketed. But since energy prices also went up, this means that the payback is going to be very short. Nevertheless, it's even why my heart is aching, that it's really great talking to you. And but why it's so frustrating, because I've been talking to the Passivhaus community for now, I think, over a decade. And we still seem to be the same small community, when we have showed the word so many times that this is almost the best thing you can do, not only for the climate. If you don't forget about the climate, just for your wallet, for avoiding having to import Russian gas, for avoiding being exposed to the for energy price volatilities, for your health, for productivity. And it's not even more expensive. So why are we still a marginal community? And that's so disappointing for me. And even though, for example, we have this amazing, and for this research that I'm showing here, for this we got the Austrian prize, national prize of the best research project in the category of sustainability. And still, it means that it may not happen. It may not be implemented. I don't want to get into reasons, because I'm sure you yourself experienced these reasons, these barriers many times. Oh, I don't know this. Oh, I don't think we can reach that U value. or the companies or the contractors have not really done this before, so they're really worried to do it first, and they don't want to necessarily take the responsibility, and it's just they're just worried if it's doable and so on. There are just many, I'm sure you yourself experience these excuses or arguments or real reasons all the time. But if we know this is a really win, you can eat the cake and have it and get paid for eating the cake and having it. But we are still not doing it at scale. And that's very concerning. And this is the only thing that I can imagine, that we all know that there should be change, but none of us wants to change. And if we continue, we really will be in trouble, because our future is determined by a sum of reducing emissions, adapting to the remaining climate change where we couldn't reduce emissions, and where we can't adapt, and there are many things to which we will not be able to adapt to, and the remaining suffering. But today we can still determine what mix of these three will our future look like. Also, now we can still choose how we want to mitigate, which technologies, which ways, and so on. But in terms of how we will suffer the impacts of climate change, if we fail to mitigate thoroughly, we will have no choice. So our future's climate depends on our actions today, and on you not allowing any other type of building to be built, and you working on making sure that every building you touch, we retrofit to net zero energy building. Because any times we miss that, we actually may be locking ourselves into a higher temperature future. Let's look up. Let's not do like the dinosaurs did. Thank you very much for your attention, and I wish you a very successful few days in which I hope, or a very successful conference, and I do hope that you will be able to inspire everyone and persuade everyone that yes, maybe you didn't do this before yet, but it is doable and it's going to be better for everyone. Thank you for your attention.
Thank you so much, Diana, for that very sobering and comprehensive talk. I do know it's very late for you. I wondered if you'd had a few minutes to answer some questions now. I'm not sure if you're planning on staying for the whole thing. Thank you. One of the questions was, I had thought that you'd said your opening slide was a certified passive house. Is that right?
Yes.
It is? Okay.
Yes, it is.
Do you have any more detail about that?
I know the architect and the company who has done it, and as I said, it's a social housing project, which is which, if I understand, it was a community building initiative. It's in the UK, and I'm very proud to say that I managed to get this photo for. But in the end, it was the working group who chose it, and we gave a lot of photographs for them on cities. They basically what they wanted, community and cities, but the team picked this particular photo. So I was very happy, because I do think that it's a conscious choice to reflect that a lot of the emphasis in our report is on the demand side. And if you look at even the industry chapter, the energy chapter, almost every chapter starts with efficiency first.
Thank you so much. Does anyone quickly have any other questions for Diana? We really appreciate you joining us, because I believe it's almost midnight. You'll be very welcome to stay for the rest of the talk, but I'll understand if you'd like to go to bed and watch the recording later. John, this question that we have is, what do you think it will take to transition the construction industry to passive house?
Very, very good question. I think regulation, because for new construction, regulation is easy. And what we see is, and if it's cheap, it's not more expensive. I just don't understand why we don't mandate it in every place already. Europe has been fairly good at progressing in this. We do have the buildings directive, but it's not really being implemented fully in a way that passive houses would become the standard. And in retrofit, it's much more difficult. For retrofit, even though it's cost effective from the perspective, it's cheaper to do a net zero passive house retrofit than buying the same energy later on for the heating. So if you calculate by how much money you saved every kilojoule of energy for which you don't need to use for heating, but still it's a major sum. So I do think we need a climate finance for that, and it's much more difficult to do through regulation. But I think building codes are definitely the way to go for new buildings.
Wonderful. Thank you so much. We really appreciate your time and your expertise on this. I'll now introduce Dr. Michael Jack from the University of Otago. Thank you very much for speaking with us, Michael.
Okay. Kia ora koutou. My name's Michael Jack. I'm the director of the energy program down at Otago, and I'd like to thank the organisers for inviting me to present at this webinar. For me, it's a really great opportunity to meet some of the people working in the energy efficiency area and to learn more about energy efficiency, because it's a pretty new area for me. And it's also really nice to follow on after Deanna, actually, because it was a talk by Deanna in Otago a few years ago that inspired me to do work in the energy efficiency area. So I'll just share my screen now. So what I want to talk about is can you see that screen okay? Okay, so what I want to talk about is, I guess, a very New Zealand aspect of this energy efficiency housing. So it follows on really nicely from the sort of global perspective that we just got. This work was done in collaboration with Anthony Murphin, who was an undergraduate student at the time, and Ben Anderson from the University of Southampton. So let's try. Okay, so many studies have highlighted the poor state of New Zealand housing, and you'll probably hear a lot more about this in the rest of the webinar. One example is that in a recent Brands report, 46% of dwellings are not heated in winter in New Zealand. A third of houses are regularly heated. Half of children's bedrooms are not heated at all, and there's visible mold in half of the houses surveyed. So, you know, there's a lot we can do to improve our housing. And I like to show this graph because I find it quite interesting. If you take the IEA statistics, you can see that New Zealand has the lowest intensity of heating, space heating, for all OECD countries, and this has been corrected for temperature. Now, at first sight, you might say New Zealand seems to be extremely energy efficient, more energy efficient than Japan with their apartment-style houses. But the fact is that our low space heating intensity is because we significantly underheat our houses compared to all these other countries. And I'm sure there'll be more talks about how high-performance housing has really proven the long-term benefits of for health, energy, and energy affordability. But what I really want to focus on here is the synergies between energy-efficient housing and renewable energy supply. So in New Zealand, we've already achieved around 85% of renewable electricity. So it's kind of obvious that our decarbonisation strategy is basically electrify everything. So this is taking transport and heat, electrifying transport and heat, and supplying that with renewable electricity. The challenge with renewable electricity supply is that there's a temporal mismatch between renewable supply and demand. So this is very easy to see for solar photovoltaics, for example, where there's this mismatch between the supply and the demand of energy. Now, energy storage can be used to help with this mismatch between supply and demand. However, it only works for a short period of time. And in this graph, the area under the curve here represents the storage requirements for this. And the trouble is that economic solutions for longer term mismatches do not yet exist. So that brings me to the dry year problem. And so this has really been clearly articulated in the Interim Climate Commission report, Accelerated Electrification. And the point here is that in New Zealand, decarbonisation strategies rely on renewable supply. And if we look at kind of business as usual, because renewable electricity is we have lots of plentiful options in New Zealand, it looks like we can get to about 90% renewable by 2030 under business as usual. So this is the lowest cost option. However, because we have a very high dependence on hydro, dry years, so when there's less rainfall, they're a barrier to greater percentages of supply. This is what the dry year problem is all about. So dry years are weeks to months of constrained hydro availability. And this is most challenging when combined with winter peaks and demand. So this is just a graph of some scenarios that the Interim Climate Change Commission ran, where they said, okay, let's have a look at trying to meet almost 100% of our our supply by renewables in the future, but then we'll use natural gas when we need to. And in their scenarios, which took a lot of historical climate data, they found that in the driest, calmest years, they still needed a lot of natural gas supply. And so this is the natural gas supply they required. And so just to give you an idea of the size of the problem, the area under that graph is around about 3 terawatt hours. Okay, so that's something that you want to keep in your mind when I explain as this talk progresses. Okay, so this is the problem. We've got the seasonal supply-demand mismatch. We've got New Zealand has a significant peak in winter, so you can see that in the national electrical demand there. That's over a number of years. In dry years, so just to give you an idea, that the area of that peak is around 4 terawatt hours, so that sort of reasonably matches with what I was showing you before. In dry years, we have the seasonal supply-demand mismatch where we can't meet that demand. Supply side and storage solutions are very expensive, so I'll go through some of those in a moment. But kind of the first question you might ask is kind of what causes this this peak in winter demand? You know, what underlies this before we start thinking of supply side solutions to it? You know, what's the cause of this? And I'd just like to show you a little clue down the bottom here. This is residential electricity supplies. So this is heating demand estimated. And I'll come back to that in a moment, but that's a little bit of a clue of what's causing that issue and what we might be able to do about it. So because of the dry year problem, MB has created this thing called the New Zealand Battery Project. And the idea is to try and solve this dry year problem. Now, there are a bunch of options that have been talked about. One of them is overbuilding renewables. And that basically what that means is creating enough renewables that you can cover your peaks. But of course, that means that in some cases you have more renewable energy than you need. And that would probably occur in summer in the New Zealand case. And you would have to, in the electricity sector, they often call that spill. with an analogy to hydro, but essentially you're losing that supply, and it means that it's an expensive option. Another option is large-scale demand interruption. So this might be turning off some very large-scale industries for an extended period of time. We're talking about 8 months here. Another option is geothermal. We have lots of geothermal energy in New Zealand. We could use our geothermal much more strategically and turn it up and down when we to follow demand. This is not really the way geothermal energy is used at the moment. It's much more of a base load. We could use hydrogen or hydrogen derivatives, green ammonia, etc., to store the energy. We could also store it using things like compressed or liquid compressed air, flow batteries, etc. The solution that is probably the one that people are most interested in is this this idea of a pumped hydro storage scheme. So very large scale pumped hydro storage, and even a location has been thought about for this. It's in Lake Onslow, and the idea of pumped hydro storage is where you have excess energy, you pump the water back up to a reservoir, and when you need that energy, you let it back down through your turbine and generate again. And so these are very, very common, the most common energy storage or large-scale energy storage systems in the world. And as you can see, this Lake Onslow idea offers about 5 terawatt hours of storage. And so MB have spent around about 30 million on a feasibility study to investigate this solving the dry year problem. Okay, but what we want to look at here is, what if we try to deal with the cause of this winter peak? And so what I've done here now is taken those graphs that I showed you before and overlaid them on top of each other. So this is the national electricity demand shown in blue. Oops. And the red dotted line shows you residential electricity demand. So you can see that they have a very good match, and what you can take from this is that essentially residential electricity demand, heating demand is driving this national peak. So because of this, we wanted to do a study of, okay, so if we went to, say, very efficient houses, would we be able to reduce this peak, and therefore this dry year problem, this winter peak problem, could go away? So this is what we set out to do. Bit of tongue-in-cheek here. As I said, we used a talented undergraduate student to do this study, so they cost about 5K compared to that 30 million. We looked for this study. We took a sort of strategic approach. So we really need to be looking on a long time period. Houses exist for a long time. You really need to consider a long time period to be able to understand the impacts. We focused on detached houses, and we could be criticized for doing this in that there are a lot more apartment buildings being built. However, at the moment, we're still getting around about 90% of our floor area is detached houses, just because they tend to be larger. So a whole lot of assumptions went into creating this stock model. So this is the total floor area of housing in New Zealand, and we considered both new houses and energy efficient retrofits, and that's quite an extreme rate of retrofit that I've shown there, but it's something that we kind of need to do if we were going to have a large impact. If we just focused on the new houses, then that would not be enough. We considered a range of different building standards for new builds and retrofits. So this should be of interest to this audience. So we looked at the New Zealand Building Code, and this was before the latest iteration. We considered a medium and a high scenario, which were related to Homestar standards. And then we looked at a very high scenario, which was essentially the Passivhaus standard, including the retrofit standard. We also looked at another scenario, which is a progressive scenario, taking the current building code and over time, over that time up to 2050, moving to a Passivhaus standard. And the idea behind that progressive scenario was really to say, if we did this really slowly, would we get the same benefits as if we did this really fast? And that's very related to Deanna's talk. We also assumed that all houses were heated to healthy temperatures. So we chose 20 degrees. We've since done scenarios with 18 degrees. The results change a little bit in number, but the basic idea doesn't change. The point here was that we, in running these scenarios, we thought, do we really want to consider future scenarios where our houses are not heated to healthy temperatures? Is that really the sort of future scenario we should be looking at? Or do we need to really just say, okay, our baseline is healthy temperatures, and let's see what energy efficient houses do from that. So this is a really important assumption, and affects our work quite a lot. But we stand strongly behind an analysis done on this basis. There's no point thinking about solutions that lock us into unhealthy temperatures in the future. Okay, so I'm going to skip how we did all this, and I'm just going to jump to the results. Okay, so what I'm showing here is the annual space heating demand of those various scenarios, and you can see the blue line up there gives you the building code scenario, and that increases significantly from where we are at the moment, and that's largely due to the fact that whenever we put in a new house or we retrofit it, we assume that it's now heated to healthy temperatures. Okay. You can also see the high and the medium scenarios, and the very high scenario down here. Okay, and also note the progressive scenario that sort of starts off following the building code, but then turns over. But by 2050, it hasn't had as much effect as doing things immediately. Okay, so we get about a 66% reduction if we would move to the very high scenario versus the building code scenario. So I guess one of the points I want to make is that in any kind of national scenario modeling that's been done, no one does anything like this. No one says that we're going to try and move to houses with healthy temperatures. It's just not put into the models, and so we think that this is a real problem, because it's basically assuming that we're going to live in cold houses up till 2050. The very high scenario shows an actual decrease in energy consumption in 2050, and that's despite growing floor area and population and heating to healthy temperatures. Okay, it's also interesting to see how this breaks down for new and retrofit, and you can see that the retrofit component is a really large component of those scenarios. So this is in the year 2050. Where is space heating demand coming from? A lot of it is coming from the retrofitted houses. So I guess the point is we can't ignore them. So the key result I really want to show you and what we, the aim of our work was really around the seasonal demand. Okay, so the scenarios I showed you before could have easily been done with sort of most modeling tools. Our approach enabled us to essentially work out a whole house R value or a whole house U value based on a building code, a building standard, and that enabled us to then take temperature data to look at what that means from a monthly level. So we could do this for, we did it for 18 locations throughout New Zealand, and this is the accumulated result. So what I'm showing here is the monthly space heating demand in 2050. Okay, and that orange line on the top there is the building code, or what used to be the building code. Our current space heating demand there is also shown in the black dotted line. And I guess the first point here is that because we're now heating to healthy temperatures, we have increased that peak in demand. We've almost doubled it. So this is sort of saying, okay, now our dry year problem has got worse because our demand has increased significantly. So that's the building code there, and the very high scenario right at the bottom, and there's an 80% reduction in area of the peak under that curve. So I've just showed you the difference in peak, but what I actually want to focus on is the area under that peak, because that's the amount of storage you require, and that's this idea of the big battery project. So yeah, here we've got an 80% reduction in peak. It's interesting that you even get a 20% reduction in peak area under the peak compared to current situation. So in 2050, if we went with this very high scenario, we would get this reduction in peak despite population growth and healthy temperatures. So if you want to know more details about this, that publication down the bottom there provides you with that. So I haven't had time to talk in lots of detail. But let's see what the impact of this is on the winter electricity peak, because it doesn't, what we've calculated there is just heating demand. What we really need to think about is what is the electrical heating demand. And that really depends on essentially technologies for turning electricity into heat. And what we want to use here is this thing called the measured heating performance factor. So this is the overall countrywide conversion of electrical energy into heating energy. And because things depend on that, we wanted to plot our results against those curves. Against that factor. Okay, so here are the areas under those peaks against those factors. All I've shown here is the building code in yellow and the very high scenario in orange there. I've also put in the area under the peak for our national demand and the residential heating demand. Okay, so they are actually different if you work out the area under the peak, but still the residential heating has a large component of that. Okay, so that's the national demand there. Now, currently we're sitting on this heating performance factor of around about 1.5, and you can compare that to, say, a heat pump coefficient of performance, 2 to 3, etc. So that means we're doing a lot of electrical resistive heating, essentially. So what this is going to do in the future is kind of anyone's guess where we sit on that line. But it is interesting to note that, at currently the very high scenario is actually gets us to 50% of the current peak at our current heating performance factor. And, we really have to get right out to a factor of 4 before the building code comes down to our current situation. So if we assume that we have extremely efficient heat pumps and they're in all houses, then that peak will reduce to that point. I also want to talk a little bit about greenhouse gas emissions, and so this is really just me doing some back of the envelope calculations, okay, because what we really care about is greenhouse gas emissions. Now, often it's said that buildings are responsible for not very large percent of New Zealand's greenhouse gas emissions, and here I'm just talking about operational emissions. The 20% figure that is often talked about is life cycle emissions. So from the building sector as well as from the operation of the houses themselves. So it kind of seems like, okay, if it's only 5% of our greenhouse gas emissions, there's not much you can do about it. There's not much room to move in terms of reducing emissions. Okay? But what I want to talk about here is, so what if the reduction in the winter peak enables greater renewable supply? Because that's going to affect not just the buildings themselves, but everyone else, because basically you've helped make New Zealand more renewable. So let's just humor me and we'll see where this goes. Okay, so if we look at our residential greenhouse gas emissions from the numbers I just showed you, we look at business as usual, we look at nearly zero energy housing. So this is essentially the passive house standard, or the very high standard I was showing you. We get a little bit of a reduction in our greenhouse gas emissions out to 2050. It's not huge. This is just due to an increase in operational efficiency. But then if we compare that to what effect we might have on greenhouse gas emissions across the whole of New Zealand, let's suppose that the winter peak reduction that we've achieved enables 55% greater renewable supply. Then we get a much larger decrease in CO2 emissions, because essentially what we've done here is we've changed the emissions factor for electricity for the whole of the country. So what I guess my point here is I want to tie some of these things together, because I don't think they should be considered independent. A whole lot of assumptions behind the numbers I just threw about. Okay, so I want to summarize now this research. So basically what I want to say is that best practice standards could significantly reduce the winter energy demand, and that could help integration of renewables and thus decarbonisation of the overall energy system. Our results for the progressive scenario show that slower implementation will significantly delay benefits. Retrofits are critical. Okay, so they make a huge component in 2050, even with our very rapid retrofit assumptions that we've made. So I guess the message, I would like to send to government essentially is that what we need is really cross-sector policies in this area that really, just echoing Deanna's statements, that we really need to mandate energy efficient residential buildings, probably all buildings, based on their wide-ranging health, efficiency, and energy affordability benefits. And the only thing I've added to this, those are things that are well known. The only thing I've added to this is kind of their role in decarbonisation as well. Before I finish, I just want to quickly talk about what we're planning to do next with our work. One initiative that is underway is that the New Zealand Green Building Council and ECA have taken this research, and they're looking at the economics of investing in energy efficiency retrofits. As Deanna said, new builds almost pay for themselves, but what about retrofits versus these large infrastructure projects? Can we actually compare like for like in those systems and see which is more economic? Is it better for the government to spend money, say, on subsidising energy efficiency retrofits rather than building a large pumped hydro scheme? We also want to take our building scenarios and actually put them in a model of the electricity system. What I've given you here is just a sort of an argument for why these buildings might have an effect, but we really need to test that. We also want to look at net zero energy buildings. So the next step from this is not just nearly energy buildings, but net zero energy buildings. And does that undo some of the benefits that we've just talked about? If you put solar PV on the roof of these houses because of the summer disconnect, does that actually unpick some of the benefits that I've talked about? Also, of course, the other thing, Deanna talked about this as well. It's not just operational emissions, it's embodied emissions. And there are ways of combining these two things together and looking at potential trade-offs between those two. So that's our future work. Finally, I just want to say, it's really critical we get this right. The point here is that we have very, very long-lived infrastructure. We have electricity infrastructure that's 40 years lifetime and buildings with an 80 to 90 year lifetime. So if we don't, it's basically the longest lived infrastructure out there. And so we really need to get moving now on this. So thank you. I'll stop there. Hopefully I haven't gone over time.
Thank you very much, Michael. I'm actually going to sneak in some questions now. We have got time for questions at the end, but I just thought whilst it's fresh in our minds, we've got a minute or two for some questions, if that's all right.
Yep, sure.
So thank you. Just going back to your early on supply and demand mismatch graph. Someone's asked, what if we add wind renewable energy source into that?
What if we add what?
A wind renewable energy source.
Yes.
Wind.
Okay. So wind tends to be. I don't need to go back. Wind tends to be quite even across the year. Okay. So it doesn't have as much sort of seasonal variation as other. Was it about this graph here? This one.
You're not sharing your screen anymore.
Oh. This one? So this is considering wind. So this is a 99% renewable electricity future. And what they mean by that is we're most of the time 99% renewable. Okay, so average 99% renewable. There are some times during the kind of the 50-year time frame that they looked at that we couldn't supply what we needed, and so that therefore we needed gas. So this assumed lots of wind.
Okay, thank you. And what population growth was assumed in the study?
Yeah, so I can't remember the details, but we basically used Stats New Zealand estimates for everything we could.
Yeah, thank you. And how do you see the adoption of electric vehicles impacting the dry year problem and overall demand?
Yeah, so that's interesting. So I guess a lot of my research has not been focusing on this seasonal side of things. A lot of my research has been focused more on sort of the daily issues, the daily demand issues, kind of what I was talking about here with solar photovoltaics. And this is of kind of immediate interest to, say, distribution companies. They really care about daily demand and what impact it's going to have, and then what impact electric vehicle charging is going to have on top of this. I guess during my research, I've kind of come to the conclusion that there are options. So there's battery storage, there's demand response, there's smart control. There's a whole lot of options for that smaller sort of daily, even sort of 2-day type mismatch. And so I put electric vehicles mostly into that category. The only caveat I would have with that is that some of our recent research, interestingly, has shown that there is some seasonal variation in electric vehicle charging as well. And that turns out to be basically due to people heating their vehicles in winter, interestingly.
Okay, thank you. So just one last question here, and then I'll save some more for the end. just obviously your focus is on heating. What consideration have you given to cooling?
Yeah. No, good point. So that's what we would like to look at in future work. Initial results show that it's quite small. It's set in Auckland, and that does kind of even things out a bit. And I guess the point there is that cooling is a very nice match for solar PV. So I'm kind of less worried about cooling as a problem. But yeah, it does smooth kind of the seasonal variation a little bit, especially in Auckland.
Wonderful. Thanks so much, Michael. Hopefully you can stay to the end for the rest of the presentations. We now have something from Dr. Ali Ghafarani Hussaini from the School of Future Environments at Auckland University of Technology, who are our co-hosts for this series of webinars. So I'll pass it to Amanda, who's our tech whiz, to put that pre-recorded session on.
Good morning, everyone. Welcome to our presentation today. My name is Ali, and today I'm representing Auckland University of Technology, Faculty of Design and Creative Technologies, and more specifically, the School of Future Environments. I would like to welcome you all to the Passivhaus Institute New Zealand event. And like many of you out there, wish that I could be there in person. However, over the past 2 years, our lives have been very different than what they were before. So I believe this is the second best option. So I'm very pleased to be here with you all. Today, I will be talking to you very briefly on a subject we call safeguarding the future. And perhaps this can motivate us to perceive what lies ahead from a different perspective. Let me start by reciting a karakia. Maori oho, Maori tu, Maori ora, kia tatu katoa, haungie, uie, taikie. School of Future Environment, as part of the Faculty of Design and Creative Technologies, is comprised of 3 main departments on architecture, built environment engineering, and creative technologies. Research is embedded in the core of our school, focusing on sustainability, being perceived from various different perspectives. In fact, AUT values and regards sustainability very, very highly. And as a result, Auckland University of Technology has adopted the 17 Sustainable Development Goals by the United Nations to formulate a highly exclusive roadmap focusing on well-being, futures, and connectivity. Speaking of sustainability, it is essential to assess how well on track we are in view to our climate action commitments. Well, a quick look at these graphs, I believe, will clearly indicate that there is a need for every single one of us to do a lot more if we really want to meet those targets, whether we're talking about 2030, 2035, or even the 2050 targets. As difficult, complex, and challenging as it may sound, there is a trajectory which has been outlined by the government that, if followed, will get us there. However, simply defining strategies will not necessarily work out. There needs to be implementation mechanisms at different stages, different layers, and different scales attached to these strategies, and monitoring bodies ensuring that these strategies and implementation mechanisms are followed. And if so, there is hope that we still can meet the targets. A major focus of many of our research works is the Auckland 2050 plan, we strongly believe that it's a highly comprehensive plan, and if properly followed and coupled with practical recommendations, has the potential to make meaningful impacts on the quality of our life in very near future. Materializing sustainability concepts, unfortunately, are not as straightforward as they may sound. In case of New Zealand, and most specifically Auckland, we have a major issue when it comes to housing affordability. Making our houses more sustainable may mean that there would be a need for a higher rate of initial capital investment. However, there needs to be proper education. There needs to be proper campaigns to inform the end users that in many cases, these initial capital investments will result in a much higher quality of life and eventually can be paid back in a certain life cycle. One of the main things that should happen, and we're very happy to see that the Auckland 2050 plan includes this as a core in the implementation criteria, is distributing equities fairly among the main 6 nodes that they have suggested for, especially after the COVID pandemic, and realizing that there are alternative ways to how we take care of our daily routines, such as working from home. The CBD has lost a lot of its traction, and now there are a lot more opportunities for people to continue working while not really having to commute to their workplace on a daily basis, burning fossil fuels, damaging the environment, and making realization of climate action even more difficult than it is now. So we need to be thinking creatively, focusing on the 6 nodes that are outlined there, and ensure that there's equity among them. On the same note, similar to many other countries, aging infrastructure is a major issue that New Zealand faces these days. As such, there's a need for major upgrade. And obviously, the upgrade works cause lots of disruptions to day-to-day activities and come at a very, very high price. Thus, we always advocate for thinking outside of the box, identifying creative solutions, and trialing notions and concepts that one day might have sounded impractical, but may fit the requirements of an emerging environment. One of which is the necessity for a cultural shift. As such, here at the School of Future Environments, we do our best to train professionals, also graduate and undergraduate level, who would support adoption of new norms for an environment which is highly evolving and resilient, flexible, sustainable, and accepting of new technologies and new lifestyles. In summary, in order to safeguard our future and the future of our following generations, there is a need to make a change to our daily lifestyle, to our routine activities, to our building industry, to how combination of our buildings form neighborhoods, how the buildings will interact with one another, and how these neighborhoods can eventually formulate smarter, more sustainable cities. It requires collaboration among academia, industry, and the policymakers. And as such, I hope Events such as the Passivhaus Institute session today and onwards can support and promote this required collaboration. On behalf of AUT and the School of Future Environments, I would like to thank the organizers for the opportunity and conclude my thoughts by reciting a karakia. Maori oho, Maori tu, Maori ora, kia tātou katoa, aomie, uie, taekie. Thank you.
Thanks so much to Ali for that pre-recorded talk. Now I'd like to hand over to Brian Berg of Kāinga Ora to talk to us in general about the what Kāinga Ora is doing in the Passivhaus space, and in particular the Ngā Kāinga Mata project. Thank you very much, Brian.
Thank you, Amy. Kia ora, everyone. As Amy said, my name is Brian Berg. I'm the manager of the carbon neutral housing team at Kāinga Ora. The role of myself and my team is to accelerate the uptake of sustainable features and solutions to decarbonize the public and supported build program. So today I'm here to talk about some of the exciting things that we've got going on in the innovation space in that public and supported housing build program, how the Passivhaus standard underpins what we're trying to do in terms of decarbonizing our buildings. And then, because I know that this is a very well-educated group who likes technical detail, I'm going to talk about some of the life cycle carbon impacts of the Ngā Kāinga Mata project as well. So to start things off, I know we've already heard from people who are much more knowledgeable in global climate science than I am, but I always just like to start off and emphasize that and ask everybody who was living in Auckland or lives in Auckland and has been working from home over the last wee while, especially in that December period and early January, February this year. I like to ask people, right, hands up if you were hot and uncomfortable while you were working from home, out of your home office. And think about now that at the moment, that is what we're experiencing in terms of thermal comfort in our homes when we're at around about a 1 degree global warming. As we heard from Diana, we're going to hit, 1.5 degrees global warming in 2030, and we're on track to be around that 2.5 degrees and beyond. So we really need to start thinking about the thermal comfort of our homes, what it's like in terms of adapting to a changing climate, and then considering as well the outdoor urban comfort and spaces between our buildings. That's not news to this audience, and but I do like to just stress that. The other point of that is, while we have such a big focus on climate change and life cycle carbon emissions, and yes, climate change is one of the pressing environmental concerns of our age, we do have other environmental concerns that we need to look at and we need to address. The chart on the right comes from the Ministry for Environment report, which you can download, and it's looking at some of the other environmental indicators and impacts, and where how New Zealand situates in terms of its own country boundary and then the planetary boundaries. The ones, as you can see, as we move out from the center out, those are the areas, that we're currently exceeding both New Zealand's limit and the planetary limit. My personal hope for all of this is that we can leverage the solutions that we develop and the will globally to solve the global climate change problem, and then also solve some of the other challenges we have, especially around biodiversity. That's one of the reasons why at Kāinga Ora, our sustainability program is focused on a much more holistic look at the environmental impact of Kāinga Ora's activities. So our vision is that Kāinga Ora builds homes and communities that support people to live sustainably. Our focus areas are up the top carbon neutral housing is the area that I lead, but we have areas of enhanced nature, biodiversity, efficient resource use around specifically our infrastructure and also construction and demolition waste, sustainable transport, climate change resilience and adaptation. And then for this audience, there would be a particular interest in our internal environmental measurement program, where we measure and evaluate the post-occupancy performance of the passive houses that we are building. I'd like to just talk a little bit and describe the life cycle carbon emissions of buildings, and then emphasize the point around it's the timing of the release of those carbon emissions is really important. If you haven't already seen the figure that I've got on the screen, please start familiarizing yourself with it. It's going to be absolutely critical for the future of our industry, and it's going to underpin how we calculate, measure, and report on the life cycle carbons of not only buildings, but also infrastructure. This figure is just breaking down how we measure and report life cycle carbon, where we're looking at the full life cycle from the product stages through the construction, the material use for maintenance and replacement and repair, end of life, and then the reuse and recovery and recycle of materials. In that operational stage, B6 and B7, we've got the carbon emissions associated with electricity use and operational water use. We've heard today about the built environment contributing about 20% of New Zealand's carbon emissions. And now this is from a consumption-based approach rather than a production. And what that means is that buildings consume carbon that has been produced by other sectors. In this way, the built environment is actually a contributor to the carbon that's released by all of the major sectors: energy, industrial processes, manufacturing, and transport. Those are through the materials that the embodied carbon of the materials we use in our buildings. Even agriculture, when we start thinking about wool-based materials like carpets. As Michael said, it's critical that we look at the whole life cycle carbon impact of buildings, because it's the buildings that we design today and it's the decisions that we make today that are going to lock in the carbon impact of our future built environment over the next 50 to 90 years. This figure is from the EMB Building for Climate Change documents that came out a couple of years ago. And it's just, again, emphasizing the importance on the timing of emissions. Now, we've got up front, we have the big initial embodied carbon. So that's the emissions associated with the manufacturing of materials, transportation of those materials to site, and then the construction of the building. That's what we're releasing now with this really large building and infrastructure boom that's underway. Over time, we've got the operational emissions primarily through the energy use of the building being distributed towards the end of the building. And then again, another peak when we look at the end of life, deconstruction, demolition, and disposal. What's really interesting is when we start applying whole building, whole of life frameworks to a large projection of the infrastructure and buildings that we're going to be building. This is some of the work that we've been doing at Kāinga Ora as part of developing our Kāinga Ora's emissions reduction plan, which is part of our compliance in the carbon neutral public sector. On the left here, you can see this is the social housing forecast, and we've taken the amount of buildings that we need, projected out over time, and we've calculated both the operational carbon, which is the light blue, and the embodied carbon. This is a total portfolio carbon assessment of the assets that Kāinga Ora owns. And so that operational carbon includes the operational energy that's used by our customers or tenants who live in our homes. Really interesting, as you can see, those big purple bars that we have right now, and that is the embodied carbon of the buildings that we are building right now. It's the What we need to do is we need to think about that reductions that we make in embodied carbon help now in this crucial period between now and 2030. And then it's the improvements that we make in the operational carbon which help protect our future. On the right, you can see we're starting to run some decarbonisation scenarios and look at what we could be doing over the long term to reduce that embodied carbon peak down, but then also make sure that as we add new buildings to Kāinga Ora's portfolio, that the operational carbon is not increasing. We need to keep that, and we even try to bring that down over time as well. The final graph that you can see on the right on the bottom is showing the emissions intensity of the options that we've looked at in that decarbonisation scenario. And you can see that the dotted line represents our baseline, our business as usual, and then these are what we would, the red line represents the jumps or the drops that we would make over time as Kāinga Ora decarbonises in line with the MB Building for Climate Change program and our own aspirations. The big point to make in all of this is that we have already factored in a decarbonisation of New Zealand's national electricity grid. So this really highlights the importance of energy efficiency and using less electricity in our buildings. We can see on the graph, this comes from research that brands have done looking at the life cycle carbon impact of New Zealand's electricity grid. And the black line that you can see is what we've used in terms of the future projection of New Zealand's national electricity grid in our life cycle carbon calculations. Again, talking and quickly presenting on some of the work that's coming out of brands and Massey University. This is work that Louise Bullen presented last year at the LCANS conference, and it's looking again at what our electricity or the carbon impact of our electricity is going to be. You can see as we decarbonize by increasing the electrification, we are going to need more electricity generated. But what we do need to do is we need to be considering, how that's going to be generated and trying to bring that in line below these dotted lines, which is a 1.5 degree planetary boundary. Have a look at the presentation. The website is listed above, and there's a lot more information in there that I encourage you to read. Okay, talking a bit more about what's going on at the moment. If you've heard me present, and I've having a look through the participants list, and I'm really happy to see many familiar names and even people that I work with on Kāinga Ora jobs. But you will have seen probably this diagram that I've put together. But what it's showing is the landscape of what's happening in terms of government carbon legislation, and then how that's going to trickle down from at the top, which is the Paris Agreement, New Zealand's Climate Change Response Act, which set up our Climate Change Commission, which sets our carbon budgets, which then we've got next month in May, New Zealand's first emissions reduction plan being released, which is going to show how the major sectors, including building and construction and infrastructure, are going to need to decarbonise in line with the Climate Change Commission's budgets. Government, as Minister Wood said, is positioning itself to lead the way through the carbon neutral public sector. And then we also have the New Zealand government procurement rules, which is all about accelerating government's uptake and the uptake of MB's Building for Climate Change program, which is under development. We've got future changes to the building code coming, with the first change, the update of Clause H1 to the 5th edition due in November. And then you can see these are some of the things that Kāinga Ora is doing, which I'll talk in more detail about how we're positioning our pilot and innovation program to accelerate and demonstrate and learn how this can all work. And that's through the use of things like Homestar and Passivhaus. But I also just want to make a shout out to other industry leading bodies and advocacy groups like the Super Home movement, who are really doing a great job of pushing forward the cause for better buildings and lower carbon buildings now and beyond. To learn more about what MB's up to, and the fact is that building regulation change is just beginning, and I encourage everybody to get ahead of it. And the first place I would recommend learning more about this is in the Brands magazine, issue 188. It's free. Just Google Brands Build magazine, issue 188, and you'll find it. And that has a number of articles that are talking about how we can build for climate change, how we can decarbonize our buildings, and then what the future of our industry is going to look like. Speaking of the future of our industry, it's always nice to look a little bit about the past history of where we've come from. So this is work that my colleagues at Kāinga Ora have been doing. This is modeling the heating demand of a 3-bedroom, 2-story standalone timber house. And I know this group will be really interested, we set the ventilation rates to keep at around about or under 1,000 parts per million of indoor CO2 levels. And then we adjusted the thermal resistance of the thermal envelope to align with the different minimum building regulations from 1977 to now, and then projected out looking at the different Homestar version 5 requirements. So we get out down the end here where we reach that magic 15 number, which is the certified Passivhaus requirement, which we've looked in and we're looking at and doing on the Ngā Kāinga Anamata project. I guess looking at this graph, I really like to point out that, we're about to take really big step forwards over the next 10 to 15 years. And you can see that we're going to do more in terms of energy efficiency and decarbonizing our buildings than we have since, pre-1977 onwards. So it's a really exciting time to be in the industry. And I'm really happy that, we have tools like Passivhaus, like Homestar to help show the way. This is again the same kind of graph, but looking at the electricity use of these buildings, and again plotting it against, in the black line, an indicative energy hardship target, which I've set at around about $25 per week. Again, we're in that stage where we're going to see, or hopefully see, transformational change coming through our sector as we move from, buildings in Christchurch requiring or having an EUI of 147 kilowatts per square meter per annum, down to reaching levels like that we've achieved on, or hopefully will be achieving on Ngā Kāinga Anamata, which is the MB Building for Climate Change draft final cap of 40 kilowatts per square meter per annum. This is the one that we all know and familiar with, and this is from the caps, the indicative draft caps that MB has put out as part of its operational efficiency framework. This is what we call Kāinga Ora's carbon continuum, and it's our interpretation of MB's proposed or draft Building for Climate Change program, with the indicative dates that they set out that we've back projected to sort of see when we will need to be working towards these different caps as they come in. One of the key things that we've been doing over the last 2 years has been aligning our innovation program to have buildings that we are designing and then constructing that are aiming for the different caps under MB's Building for Climate Change program. in the center here, you can see some of the innovation projects that we have underway. Beta Harvard, Beta Ventura, and Ngā-Kāinga-Namata. Those are all 3-level walk-up apartment-style housing, all located in Auckland. And Beta Ventura is aiming for the Passivhaus low energy standard. Beta Harvard, sorry. Beta Ventura is aiming for certified Passivhaus, or I'm going to call it Passivhaus Classic. And then Ngā-Kāinga-Namata is aiming for, again, the Passivhaus certified standard, but we've also integrated in renewable photovoltaic panels, and we're aiming to achieve net zero energy status. And then we've looked at the embodied carbon impact of that building as well. Everything we're doing on this carbon continuum is about researching to understand how we design and build to the Building for Climate Change program's ambitions. What are the life cycle costs? What are the life cycle benefits? Most importantly, monitoring and evaluating these buildings throughout design, construction, and post-occupancy to ensure that the benefits of these buildings are actually realized for our customers in reality, not just on paper. But most importantly, I think we want to make sure that we're sharing the learnings from these projects as they come along to the industry to show the way that it can be done, and it can be done with today's technologies. The Beta Passivhaus projects, these ones are really special. They're underway in under construction right now. And I'm really pleased to see that a number of our project partners in the design team are actually on this webinar at the moment. So I just want to say thank you so much to all of our project partners for their hard work in making this, really come to life and possible. The special thing about these beta drive developments in Mangere is that they're all located in the same area, which you can see on the map. But we have Beta Harvard, which is the low energy standard, and we have Beta Ventura, which is the Passivhaus standard. So we're going to monitor and evaluate both of these buildings to see how the different standards work in reality. And we also have the same design and construction team working on both projects. This is sort of a snapshot of the architectural renders from Petalthorpe. So Ngā-Kāinga-Namata. Just want to acknowledge the people who we've worked with on this project that have really they've done all the hard work. They've made it come to life. Ngā-Kāinga-Namata, we entered this project into the COP26 Built Environments Virtual Pavilion that was launched in November last year. That virtual pavilion is still live. We're Project 11. You can log on. You can see more about and learn more about the project. We have our sustainability report online, and we have a number of videos. It's also really an important thing, I think, to emphasize is that we're not the only Passivhaus project that was a finalist on the pavilion. There were 17 other projects. These were selected out of a pool of around about 900 global entries. And of the 17, there are, I think from memory, at least 4 or 5 Passivhaus projects on display, including the Monash University Passivhaus building in Melbourne. So talking about the life cycle carbon impact of the Ngā-Kāinga-Namata project. On Ngā-Kāinga-Namata, we took a science-led, evidence-based decision process when we were designing out the life cycle carbon impact of the building. One of the first thing we did was conducted a life cycle carbon assessment with brands and evaluated the carbon performance of our standard typical construction. From there, that's the results that you can see on the bottom here. The different colored bars represent the different life cycle stages. From here, it was fairly obvious that we needed to focus on the operational carbon through the energy use and maximize the co-benefits of solving energy hardship and making it warmer, drier, healthier for our customers. That led us down the pathway of utilizing the Passivhaus standard to do that. We also at the time, were keen to explore, what the Passivhaus standard would mean for Kāinga Ora, as, it has been held up and recognized as an international benchmark in social housing quality, with notable examples such as Exeter Council in the UK. From there, we moved through from concept design through to developed and detailed design, and we looked at how the different structural systems for these buildings could work. I've only presenting the results for the cross-laminated timber option, and it's important to note that these results include the biogenic carbon sequestration of that timber. On the sustainability report in Ngā Kāinga Anamata, you'll be able to read more about the biogenic carbon sequestration. We actually present the results both in including and excluding, which is in line with international best practice. So overall, by applying the Passivhaus standard in conjunction with CO2 hot water heat pumps, the photovoltaic panels to achieve net zero energy, and CLT, we're able to reduce the life cycle carbon impact by around about 73%. We did focus on the embodied carbon impact of the building as well, and a conscious effort was made to select low carbon materials and products where we could, and where we couldn't, we prioritized the use of materials and products that had environmental product declarations, and these are some of the ones that we have used listed. This is how we calculated the life cycle embodied carbon of the building, and yes, we did include the embodied carbon of the photovoltaic panels. That's why you can see those up the top as the highest, most contributing material to the life cycle embodied carbon. One of the really interesting things that and you need to consider when you're designing the carbon for reducing the carbon impact of buildings is to think about, again, the timing of the emissions and where that carbon is being used throughout the life cycle of the building. One of the results that always surprises me is about the impact that carpet has on the carbon impact of buildings. And in this CLT build, the Passivhaus option, it's the second highest carbon contributor. That's really due to the maintenance, but also the replacement of the carpet, where we've assumed that it needs to be replaced between every 10 to 15 years, and again over a 90-year building lifespan. Getting close to wrapping up now, but I do have some more slides which we'll make available. But I just want to leave and sort of say, while we reduce the carbon impact by 74%, and that's a really, good first start, where it's job started, it's not job completed, we're still 1.4 times above a 1.5 degree carbon budget for new residential construction here in New Zealand. That's the Brands and Massey University carbon budget. These results I actually need to update now because every year that we aren't decarbonizing globally, there's less carbon for our new builds to use. And so that while the dotted line you can see plots that carbon budget per occupant housed, in reality, when we consider the timing of emissions, we actually have less and less carbon every year as we move out towards 2050. These are some of the things that you can do to design embodied carbon out of your buildings. And again, re-emphasizing that this cuts emissions now, not in the future. I would just like to say, building smaller homes is absolutely critical. It makes buildings cheaper and it also saves carbon. Really, we need to be thinking about the use of glazing in our buildings. Again, it saves money, it saves carbon, it reduces overheating. And then I'd also really like to encourage everybody to start doing building life cycle carbon calculations on their builds. It might be that you only do it on one project, but start doing it now. Start learning what it means, how to do it. So then when we get to 2024 and MB brings life cycle carbon reporting into building code, we're all ready to go. There are a number of things you can do now. There are a number of tools. There's a whole bunch of information. And I would suggest one of the best things you can do for keeping up to date is to get on LinkedIn, follow organizations like One Click LCA, like eTool, like NZGBC, like Passivhaus, like Jonathan Holm, who's I know on this webinar. He's a fantastic person for putting out insightful and educational posts on LinkedIn. And I'm really proud to say, that, we can do all this right now. We have all of the solutions available to us. It's just up to us now as an industry to start doing it at pace and scale. Final slide, I just want to say, one of the things that I'm going to be doing at Kāinga Ora over the next year is we released earlier in January, I believe it was, an RFP for a carbon measurement and reporting tool. As part of our decarbonisation aspirations and in line with the carbon neutral public sector, we need a tool that we can be using and deploying on every public and supported housing project so that we can calculate, measure and report on the carbon impact of those buildings, and then use that tool to improve the energy efficiency of them, design out the embodied carbon, design out the operational carbon. So watch this space. And I'll finish up there. Thank you.
Thank you very much, Brian. We just got time for a few questions. So we do want to wrap up at 11 o'clock. So just say, what's Kāinga Ora's view on the level of passive house upgrade, low energy building versus full passive house, taking into account energy load instead of energy demand? I'll just read the rest of that question. So the energy load with an efficient heating and ventilation system can easily reduce the actual consumption to less than 15 kilowatt hours per metre squared per annum, even if the demand is 30. I think you probably can view the questions yourself, Brian, if I've not...
Yeah, that one I might need to actually just reflect on. So I think what we'll try to do is, there's a few questions here. I'll try to, I'll get hold of them and distribute some answers. I'm sorry, I didn't quite follow that one.
Yeah, okay, no, that's a good idea, because I don't think we'll have time for all the questions. So one that has come in I would like to ask is, now Kāinga Ora have shown what they're capable of doing, will they increase from the minimum Homestar 6 up to Homestar 8, 9, 10, and or do a lot more passive houses?
Yeah, that is a good question. What I'm going to have to say and how I answer that is that we have the innovation program in place for a reason. We need to, actually finish up and learn how these buildings, how they work, how they perform, how ready the sector is, bearing in mind we've got a balance. We have budgets that we need to meet. It's public money that we're spending when we're building these buildings, even though they are, a form of social infrastructure for all New Zealand. But we do need to consider, how ready the sector is, supply chain and procurement issues as well. So while I'm not in a position here today to, make any promises, what I can say is that I'm really excited about the projects we have underway. The Beta Ventura Passive House project in particular is under construction at the moment. And we do have, comms events planned and a webinar planned shortly this year around and to hear from the design team about how that building is coming together and how it's working. So, sorry, I'm going to have to just sort of leave that answer there.
That's fine. Thank you so much, Brian. And I think we will leave it there so that we do finish on time. Thank you for everyone for your attention for the last 2 hours, and thank you to all the presenters. And just wanted to highlight that we've got some more webinars coming up in our Passivhaus season. So we've got details to be confirmed, watch this space, but the next one will be on the 27th of May on social housing. And then we've got Enerfit, which is the retrofit standard for Passivhaus. And then finally, schools and community. Thanks, Amanda, she's just put them up there. So those are the dates and the details, and shortly up on our website, you'll be able to register for those. Thanks everybody. Have a great day. Have a great weekend, and we'll see you again soon.